All right, so we have been working with linear relationships, and right now we're gonna dissect this linear equation. It's basically in slope-intercept form. So the first thing I wanna talk about are my variables, where x is my independent and y is my dependent variable. The reason why y is dependent is because it literally does depend on what we put in for x. What we put in for x will then result in what y is. M in this case is where we put our constant rate of change, our slope, and also your difference in y over difference in x, which is your rise over your run. And then lastly, B here, this is our y-intercept. This is where when you graph this equation, it's where the line crosses the y-axis, so it's a coordinate point when x is 0 and y is exactly what B would be in the equation. So let's go ahead and do these 8. I'm gonna do the first one with you and then you can pause it and do the next 8 and we'll go over a couple of them. So here we go. The slope, we already talked about, is the m in the equation. It's in front of the x, so a 2 is in that place, so 2 would be the slope. Y-intercept is what's being added in, just like here. So, but we write it as a coordinate point when x is 0, so 0, 4, and our independent is still x, our dependent is y. So can you fill in the next 7 and then pause it for right now, fill in the next 7 and then we'll go over it. Okay, so a couple that may have been a little interesting. This one's pretty straightforward. This one, however, a common mistake is for people to put 0 in front of the x here because there's nothing there and calling 0 slope. But if you actually put 0 in front of x, 0 times x is just 0. So if you have our 0 plus 3, that's just 3. So your equation would actually read 3 equals y, when indeed it's x plus 3 equals y. So there actually is a number that hides in front of this. The number is 1, because 1 times anything is just that thing it's being multiplied by. So if I do put a 1 in front of here, it does not change the equation. However, it does show me the slope. 1 times x is just x, so my slope is 1. My y-intercept is still adding in the 3, but it's written as a coordinate point, 0, 3. X is independent, y is dependent. Here, don't be afraid to have a negative slope, that's okay. It just means when it's graphed, it's gonna go down from left to right. Here, these are both interesting, as if you notice, in the equation there's subtraction, when in our slope-intercept form up here it has to be addition. So we need to change these subtractions to addition by adding the opposite. Y equals 7x plus negative 4. Now we have it in the correct format, making my y-intercept 0, negative 4, and my slope still 7. And of course, independent is x, dependent is y. Okay. All right, so let's move on to the table down here. The table here, we can actually find our slope by doing rise over run, or difference in x over difference in y over difference in x. So here we would want to find out that x is indeed going up by 1. That's always helpful. And then if this is going to be linear, the y is going to change at a constant rate or go up or down by the same number each time. So from negative 3 to 0, it's going up by 3. From 0 to 3, it's going up by 3. And yay, it is going up at a constant rate of plus 3 each time, so it is linear, making my slope the difference in y over difference in x, or rise over run, which is 3 over 1, making my slope simplified to 3. My y-intercept is when x is 0, 0, 3. Now I have to put this in equation. I'm still going to use my y equals mx plus b equation, where I use y and x, I replace the m with my slope of 3, and I replace the b, which is the y-intercept, with my actual y-intercept. So y equals 3x plus 3. Independent is still x, dependent is y. So please pause now and do the next 3. Okay, you may have found in this one that while x still goes up by 1 each time, my y is changing at a constant rate, but it is going down 1. Therefore, my slope is going to be that -1 over 1, which equals negative 1. My y-intercept is the 0, 8, when x is 0, y is 8. In my equation, I can write it a couple different ways. The first way would be y equals, replace my m, my slope, with my actual slope, negative 1x. I'm going to add in my y-intercept. But just like we had done in the other problems, when you have a 1 in front of x, you can just do the multiplication, but this is a negative 1, so negative 1 times x is actually negative x. So my equation could be written y equals negative x plus 8, but either one are fine. Okay, let's go ahead and turn it over and do some of the graphing now at this point. First thing I want to notice when we're dealing with graphing is we're still using the y equals mx plus b format. We still have to find the slope, still have to find the y-intercept and this equation. However, we have to get all the information from the graph. Now we have the line and it tells us everything. First thing I want you to notice is it is going up from left to right, so therefore the slope is going to be a positive slope. It is going up as x is going up. So I want to find where this line crosses the corners of the grids. It makes it easier because you can find exact coordinate points. Okay, I notice that it is going up 2 over 1. Up 2 over 1. So my rise over run is 2 over 1, which gives me 2, making my slope 2, and indeed that is positive. I find my y-intercept where the line crosses the y-axis. This is at point 0, 8. And now I can write my equation by plugging this in just like we did from the table. Y is always first here. My m, which is my slope, is 2x. I'm adding in the 8, which is the y-intercept, and of course, independent variable is x, dependent is y. Go ahead and do the next two. Make sure the first thing you check out, though, is the direction of the graph. Notice this one, the first one, is going up from left to right, where the second one that you're working on now is going down from left and right. So please make sure you change the slope accordingly. When you're finished with this whole worksheet, bring it up to me and we'll check your answers.